Okay, good morning. So I've created your quiz, so you should see your points. If you already submitted through the Canvas or email it. So if you don't see your grade, just let me know where is your quiz, and then I will grade it for you. And you should also have your points for your assignment so far. Okay, so double check that one. If there's anything wrong, just let me know. But try to submit through the Canvas, so then I would be able to give you a feedback. Okay, so that's going to be one. So the next step, it's going to be your test. We have a couple of more things to cover today. Then I've already posted a practice test for you. So your test is going to be, I think, next week, next Tuesday. So we're going to practice, we go over the practice test on Thursday, and we give a test on Tuesday. So what we did the other day, we talked about the section, I think that was 3.2. We talk about the measures of variations. We introduced standard deviation, the variance, but there was one more thing to do. This is the one that I talk about it, that give you a tool to be able to locate where the data values, a specific data value is going to be, okay? So the theorem is classic result. We call it Chebyshev theorem. So you may get one question. There are two cases, and probably we get one question from this one on the test, okay? So this is what we're going to do. Any question? So let's go back to see where we end up. And this is what I was talking about. You see, so what we would like to do is, these are going to be the number line that we usually identify the X values. Then there is a center. The center is going to be X bar. Then we would like to know what is going to be the data values, a specific one. How we are going to compare it to the X bar. Where is going to be the position. So we decided to compare them according to the number of the standard deviation to the right or to the left. Okay, so I just identified this is 1 standard deviation, 2 standard deviation, 3 standard deviation to the right, and these are going to be to the left. So to the right, you are going to be above the mean. To the left, you are going to be below the mean. This theorem that I'm going to talk about it will tell us how many data values are going to be between, 2 standard deviation from the center. So the range is going to be X bar minus 2s and X bar plus 2s. 75% of data values. It doesn't matter whichever data values you collected, this must be true all the time, at least 75%. Then if you would like to know how many of the numbers are going to be in the range of the 3 standard deviation from the center, that number is at least 89%. So whatever you do, 89% of your values must be within the 3 standard deviation from the center. If you want to do it at any percent, that is the Chebyshev theorem. If you are going to be k standard deviation from the center, at least 1 minus 1 over k square percent of the data values must be between these intervals. So I'm going to make it official. It's very nice result. It can be proved, but there is another one that depends on the experience. So get to know the name and be able to apply it. It's going to be 2 types of problems. The range would be given to you, identify the percent. The percent would be given to you, identify the range. Or the second part, only 89%, and the 75% would be given. Let's introduce it, then we take those problems too, okay? So in your book, they like it, and you have a number of the problem in your assignment. So get to know it, okay? So it's a Russian mathematician, Chebyshev. Okay, this is it, Chebyshev's theorem. This is maybe this is his only result in statistics. He got many results in pure mathematics. So if you study something advanced mathematics, you will see a Chebyshev function, Chebyshev inequality, Chebyshev norm, Chebyshev space. It's all over the places, really. You got such a great ideas and theorems in advanced. We call it analysis, mathematical analysis. So this is it in general for any given data values, okay? For a given data values or data set at least. Okay, at least the minimum. At least a 1. Make sure to write it down correctly. Okay, 1 over k squared percent. Okay, 1 minus 1 over k squared percent of all the values of data values. Data values must be in the following range. R between k standard deviation from the center, means between x bar minus k times s, comma, or and x bar plus k times s. So there's going to be an interval that you can find it easily because the s and the x bar are all available. Okay, so for any given data set, 1 minus 1 over k squared percent of the data values are going to be between these two numbers, okay? Or in other words, this is the way they express it. We said that it's k standard deviation from the center. So those values, it will fall, those numbers, within, okay, within k standard deviation, within k standard deviation from the mean. Standard deviation from the mean, from the center. Okay, so that's a general one. There are two of these numbers that are most common or most commonly used. So we are going to check those. Now, in particular, two cases. If k happen to be equal to 2, to a standard deviation from the center, if you do the algebra, you see, then this 1 minus 1 over k squared, when k is equal to 2, is going to be 1 minus 1 over 2 squared, which is going to be 1 minus a quarter, and minus a quarter would be 3/4. Okay, it's going to be 3/4, and the 3/4 is 0.75. Okay, it's going to be 0.75. It's like 0.75%. Okay, so in this case, 1 minus 1 over k squared percent that we talk about it is going to be equal to the 75%. That give you that a special case. Okay, a special case that so this is going to be this is one of those percentages that you have to know it. It's or if they're given to you, you must know that 75% correspond to the k equal to 2, or k equal to 2 correspond to the 75% of the data values. So the conclusion is going to be, so at least, okay, at least 75% of those values, okay, of data value for any data set. Data values are going to be in this interval, are going to be, okay, in this interval, or are between 2 standard deviation from center, between x bar minus 2s and x bar plus 2s. Okay, that's going to be fine. Or in this interval, the interval of x bar minus 2s, comma, x bar plus 2s. So that would be the range for the 75% of your data values. So if they tell you 75%, easily you are going to find this one because they ask for the range. You have the X bar and the S, you must know that this is a 2. So you substitute, you give them the range. Or if this range is given to you and they ask you find the percentage of the data values that are going to be in this interval, you must know that 2, K equal to 2 and K equal to 2 correspond to the 75%. Okay, so you must know, be able to operate either way if you like. Any question? So that's for the K equal to 2, that gives you 75%. There is another popular number is K equal to 3. Most of the time, this is going to be the one. Okay, are you done? So another easy case that we have to consider, or important case that we have to consider, is this one. Okay, so let's say similarly, we are going to have a similar one here. Okay. So similarly, if K is equal to 3, if K is equal to 3, then if you go to that formula and simplify it, you see if we go to the formula of 1 minus 1 over K squared, so that gives 1 minus 1 over 3 squared, which is going to be 1 minus 1 over 9. You know that this would be 8, 9. 8, 9. 8, 9. That's going to 8, 9, and 8, 9 is going to be almost something like 0.89, which is 89%. So it's not exactly 89, it's almost 89. So in this case, 1 minus 1 over K squared percent would be 89%. Okay, so 89% would be correspond to the K equal to the 3. And then we find out that if this is going to be the case, so at least 89%, almost all of them, 89%. Okay, so the conclusion of this is going to be, this is, again, this conclusion, you have to know it and you can use it anytime you like. So at least, okay, so at least what? At least 89%. 89% of data values. Okay, of data values are going to be within 3 standard deviation from the center, are between, okay, between these numbers, X bar minus 3s and X bar plus 3s, or if you like, or in this interval, the interval of X bar minus 3s, comma, X bar plus 3s. If it's happened to be any other number, you have to find it yourself. There are a couple of cases that that percentage is not popular. It's not 75, it's not 89. So you have to find the K yourself. Okay, the K would be given or you are going to find it. So you may have K equal to 2.5. If you have K equals 2.5, you have to substitute as I did it over here. Okay, and you have to substitute it and then you got the percentage. You may get something like 83%, 75%, 54%. There's one in your book, we are going to check it. That gives you something like 55%. So we are ready for it. Okay, any question? So it's a good measures, if you like, to find these numbers, but we're going to have another one, a better one in future. But it's nice. It's very classic results, kind of algebra. Okay, so we have to check 2 different cases. Any question? So let's say I'm going to be question on this one. Look at this one, the first one. And you have a 2 on the practice one that I posted for you. Okay, and we check the solution on Thursday, but you can have a look. So what's going to be the example? Example like you see, you know that the mean price, okay, the mean price, it's given that the mean price of houses, mean price of houses, in a certain city, is going to be, let's say, $50,000. It's not probably in California. Okay, so the mean price of houses in a certain city is $50,000, and the standard deviation, the standard deviation is $10,000. Okay, $10,000. So always it is the case, X bar and the S would be given to you. So what's the question? We're going to ask you two questions. And the first part, the question is going to be, we want to know, find the range of the price. Find the range. Find the range for which, at least 75% of those houses will be sold. Of the houses will sell. See, that's going to be the one. So according to the Chebyshev theorem, you must know that 75% corresponds to the true standard deviation from the center. So you know that at least 75% of your data is going to be between what? X bar minus 2s and X bar plus 2s. You substitute, you get your result, okay? There are two cases. Let me just give both of them, then we do it. This is the type 1, that you must know that the percentage corresponds to how many standard deviation, okay? So the next one is going to be, again, find the range. Find the range for which at least, almost all of them in this case, at least 89%. Okay, 89% of the houses will sell. Houses will sell. Again, you must know, according to the Chebyshev theorem, 89% refer to the 3 standard deviation from the center. So that range would be X bar minus 3s and X bar plus 3s, okay? So 75% refer to the K equal to 2, 89% refer to the K equal to 3, and we substitute, we get the result right away. Any question? Just do it. So for part, all the information that we have, generally we have the X bar. Okay, we have the X bar, that's $50,000. Okay, and you have the standard deviation S, the standard deviation of the 10,000. Okay, so we go to the part 1 and the part 2. In part 1, 75%, I just explained it for you. You can do it right away. So I just remind you that by the Chebyshev, okay, by the Chebyshev's theorem, okay, by the Chebyshev theorem, at least 75%, at least 75%, just to remind you, of data values, are going to be in this interval to a standard deviation from the center, X bar minus 2s, okay, comma, X bar plus 2s. So go and find it. Okay, so find out what's going to be X bar minus 2s. X bar is the mean, is given to 50,000. Okay, minus 2s, s is 10,000. So that would be 10,000. So it's going to be 50,000 minus 20,000, which is going to be 30,000. Okay, that would be the lower range if you like. Then we are going to do the other way around, X bar plus 2S, which is going to be, this is it, 50,000. 50,000 plus 20,000. So that would give us 70,000. Okay, so that will tell us that 75% of the houses will be sold in the price range of between $30,000 and $70,000. Okay, so this means at least, just explain it again, at least 70, but you have to give us the range. At least 75% of, okay, of all homes, if you like, or houses sold in the area with this range, in the area. Okay, in the area we'll have, if you like, we'll have a price range. We'll have a price range from, okay, price range from $30,000. Okay, $30,000 to 70,000. So that give you a nice idea of, you know, what's going on with this house prices for that, you know, for that specific region. Okay, that is going to be one. 75%, we talk about it, 75% refer to what? Refer to the true standard deviation by the Chebyshev theorem. You must know it. This is a theorem that we talk about it. You see, that's it. 75%, this is your interval. X bar minus 2S, X bar plus 2S. And this is exactly what I use. X bar minus 2S, X bar plus 2S. So you must know it yourself that 75% refer to the 2S standard deviation from the center. Any question? So that's the first part. So that's the first part for 75%. We have to repeat it again. For the second part for us for the 89%, we know that 89% refer to the 3 standard deviation from the center. Okay, are done. So quickly, we take care of the second part. Same thing. You see, one of them or maybe both of them usually ask. So for the second part, it's just same argument. I just explain it again. You can go ahead and just put k equal to 3, we accepted. But I just remind you that again by the, okay, by Chebyshev theorem again. Okay, that's it, Chebyshev's theorem. At least, again, I repeat that theorem, at least 89% of data values are going to be in this interval, in the interval of X bar minus 3S, comma, X bar, okay, plus 3S. Because in this case, K is equal to 3. So get these numbers, X bar minus 3S, X bar minus 3S, X bar 50,000, minus 3S, S 10,000. So that gives us a 50,000 minus 30,000, which is going to be 20,000. Okay, the range from $20,000 for all of them, of course. And the X bar plus 3S, X bar plus 3S would be 50,000 plus 30,000 here, which is going to be 80,000 this time. So generally for almost all the homes in the region, will be sold in the price of price range from $20,000 to $80,000, because 89% consider it to be all of them. Okay, so the conclusion is going to be 89% of all the homes will have a price range, will have a price between between $20,000 and $80,000. And that would be, that would be good information if you like, to have it. Chebyshev theorem cannot give you anything within one standard deviation, because that formula is 1 minus 1 over k squared, remember. You're not going to have anything before the 1, but you can have anything and k is bigger than 1. And there is another one, we call that one empirical one, means, we just learn it through the experience. That would give you that one standard deviation too. That range is, it's somehow better. It's something that we get, I think 68% or 65% within the one standard deviation. And that range, 89% would be great, would be upgraded to something like 99%. But, we'll get to that one later. We don't want to compare it now. Okay, so that's the first problem. The first case. Percentage would be given, you identify the range, you need another one. The other one is the range would be given, you have to identify those percentage for us, okay? This is more popular to get the second part. Any question? So let's see how they are going to express the second format for you. So that would be the other way around. The range would be given. So this problem is, you know that when you go to this gas station from one to the other one, the prices are going to be different. So we are going to have a comparison for those prices. So that's it, the average. Okay, the average price. And the average price of a regular gasoline and needed gas or gasoline, excluding taxes. Okay, excluding taxes, say in USA, was $3.06. Okay, per gallon. Okay, that's going to be per gallon. So the average place is going to be X bar. So the X bar is 3.06. Let's continue. The standard deviation must be given. With the standard deviation. Okay, standard deviation of 6 cents. Okay, that's it, 0.06. So that's the situation we have. We have the X bar 3.06 and the S of 6. So what's the question? The question part one is we want to know what is the minimum percentage of gas station. What is the minimum? Okay, minimum percentage. What's the minimum percentage of gasoline? Okay, of gasoline stations. Gasoline stations that had this range price. Okay, that had prices between Okay, prices between $2.94 and $3.18. Okay, that's going to be what? So we have a range price. We want to know what percentage of gas station would charge this range price for us. Okay. So in this case, you have the range. You see, you have the range. You have to find the K yourself. You just, you just identify if K is given to you. Remember, if K is given to you, the range would be X bar minus K times S, and the X bar plus K times S. K can be 2, 3, or any other number. Okay, that's going to be what. So this is going to be the case. And so, it's going to be just algebra, really. The algebra that this is going to be K, this is going to be X bar minus K times S. You have the X bar, you have the S, you just let these to be equal to the X bar minus K times S, you solve for K. So if K happen to be 2, then you have to tell us that refers to the 75%. If K happen to be 3, you are going to tell us is referred to the 89%. That's going to be any other number you have to find out, okay? So I should give you one more. This is going to be a standard. If you check it, you may get K equal to 2 or 3, but this next one is more interesting to know. Okay, same thing. We want to know what is the minimum? Okay, what is the minimum? Again, percentage. Minimum percentage of same thing. Gasoline stations that had this range. Price range. What's the price range this time? The price range is going to be, or the prices between, okay, prices between this time at $2.91 to $3.21. Okay, so that's going to be the range, the new range. Okay, so the range is given, you ask for the K. So you have to note this one. I just, you can do it right away, but I just to let you know that generally this is how we're going to do it. So, oh, note that, I know that. Note that 1 minus 1 over K squared percent, just the theorem of data values, are in this interval, What's interval? X bar minus K times S, comma, X bar plus K times S. You know that. Within the K standard deviation, okay, K is standard deviation from the center. Now for each case, just bring the given interval, let it to be equal to the one that we have here, and so for K. Okay, so in this case, you don't have the percentage. So we take the first one. Okay, part one. You see the one that you have is what? The price range is for first case is 294 and 318. So 2.94, comma, 3.18. You let it to be equal to the general interval. X bar minus K times S, comma, X bar plus K times S. That's it. Okay. Now these are going to be two order pairs. So when they are equal to each other, their corresponding components must be equals. So for example, these two must be equal to each other. And also these two must be equal to each other. So we just pick one of them and get the result right away. Because you want to find the K. You want to find the K really. A different way to do it. You can subtract it and divide it by S, or just this is going to be the easy one. Okay, so I usually go with the first one. So I let X bar minus K times S to be equal to the smaller number. If you don't like it, you can do it now. You can do the other one. So you let this one and you solve for, okay, solve for K. This is the way we're going to do it. So we need to put in the X bar. Remember the X bar, the average price of the gas stations. So we have X bar is equal to 3.06. It's given to you. And the standard deviation of all the gas station was 6 cents. So it's going to be 0.06. Substitute here and solve for K. So it's going to be 3.06. And got to be careful. There are going to be decimal numbers all the time. Minus S is 0.06, substitute here. So that give you 0.06 times K is equal to the 2.94. Any question? We just substitute. You see, that's it. Your X bar 3.06 minus K times S, and the K is missing, but the S is 0.06. Now we can subtract the, move one of them to the other side, or subtract. I just, isolate this one, or subtract 3.06. Okay, so this is going to be the case. It's going to be negative 0.06. K is equal to what? Is equal to the 2.94 minus 3.06. Okay, you subtract this number. So the result is going to be, you get the negative 0.06 times K equal to, if you subtract this one, okay, 4 out of 6 would be 2. And that gives us 1 point. It's going to be 0.12. Okay, 0.12, and so for K, I put it over here. So the K is going to be equal to the negative 0.12 divided by negative 0.06. If you drop the decimals, you have 12 over 6, which is 2. Okay, so K is equal to 2 for the first part. Okay, but remember, you're not done because they ask for the percentage. Okay, minimum percentage. So we know that K equal to 2 is corresponding to the 75%. So we have to explain it that 75%, I'm going to write down on the next page. Any question? So I just did the lower range, if you like. You can do the upper range, it doesn't matter. X bar plus K is equal. You don't have to do both of them, okay? Just one of them would be fine. So I did the lowercase. You can do the uppercase if you like. But you have to explain it. You're not done. Any question? So we explain that this is K equal to 2, and we know it. We know that K equal to 2 refer to the 75%. If it's going to be an unfamiliar number, you have to do it yourself, okay? You have to find it yourself. How did I get the 0.12? I subtract. That's it. 2.94 minus, that's it. 2.94 minus, you subtract. 2.94 minus 3.06. 4 out of 6 would be 2. 9 out of 10 would be 1. You carry 1, 2, and 3 would be 3. So negative 0.26. Okay. So we have to explain it that what does it mean? The K equal to 2. So K is equal to 2. And so you explain that at least 75%. 75%. They ask for the minimum. The minimum would be 75%. That's it. 75% of prices Our prices are going to be R between, okay, R between $2.94, okay, 94 and $3.18. So that's going to be first part, okay, or just 75%. We accept it. Any question? So that was the first part. The first part, the price range was familiar, okay? So we check another one. It may be not familiar, but we are ready for it. Okay, are you ready? The second part, bring the range. The range of prices this time is $2.91, okay, and $3.21. Yes, that was the one. Yes, $2.91, $3.21. Okay, that's the second range. So let it to be equal to the general range that we have. General range is X bar minus KS, comma, X bar plus KS. Again, you have a choice. They must be, their components must be the same. You can use the lower range or the upper range. So I'm going to use the lower range. Again, you see these two. Let them be equal to each other and solve for K. So it's going to be X bar minus KS is equal to the $2.91, or the other one, doesn't matter. Again, bring the X bar. Remember, just to remind you that the X bar was, okay, X bar was 3.06, and the S was 0.06. You substitute and you solve for K again. So if you substitute this time, you're going to have a 3.06 minus, again, minus 0.06 K, which is equal to the 291. Okay, so for K, it's going to be negative 0.06 K equal to, again, we have a 2.91 minus 3.06. Subtract again to get this number. So it's going to be negative 0.06 K. If you subtract that, give a negative number, like the one that we did before. 1 out of 6 would be 5. Okay, and this would be 1.0. If you subtract 2.91 out of 3.06, and so that gives a 0.15. So the K is equal to the negative 0.15 divided by negative 0.06. Okay, use your calculator, or if you simplify that, give it 15.6. Because negative positive, you drop the decimals. We have 2 decimal places on the top and on the bottom. Okay, so we drop all of them. So it's going to be 15/6. 15/6 is going to be what? Is 2.5, I think. Yes, that would be 2.5. Okay, so K is equal to 2.5. You see, you are not done. Remember, you must identify the percentage. K 2.5 is not a popular one because we know only K equal to 2 and K equal to 3. So what you have to do, you have to go back and substitute in the formula, okay, to get the result. But what is the formula? The formula is, that's what I was talking about. It's not always the case that you get, K equal to 2 or 3. You can have any K number. So go back to the 1 minus 1 over K squared, okay? Substitute 1 minus 1 over, that would be 2.5 squared. Okay, 2.5 squared would be, it's going to be 1 minus 1 over 6.25. You can use your calculator if you like, but if you want to continue, you have to put 2 zeros on the top and make this one into 1 minus 100 over 625. Okay, to match the number of the decimal places that we have. So this would be 625 common denominator. and that would be 625 minus 100. So we go on, we simplify it. The bottom one would be 625, and the top one would be 525. Okay, you can use your calculator to get this number. Okay, so I have a 525 divided by 625. So that give me, 0.84. So it's going to be 0.84, which is the same as 84%. You see, it's a kind of percentage that you have to find it yourself. So for this new range that give us, so 84% of those prices or the gas station will have the price range in this, in this format. Okay, so you make a comment that 84% of prices are going to be between this new range, the range of, the range that we got over here for this new one, it's a $2.91 and $3.21. Okay, so you got to be prepared for it. So in case if it's going to be any other range, you have to find out yourself. Okay, so this is going to be the case. Yes, if you have a decimal numbers over here, you have to match them. If you don't want to use calculator, you have to match the number of the decimal places first, then you are going to what? You drop it. This is like, it's like a 0.00. You see, if you drop the decimals, that give 100 over 65. Or you can simplify it, I just want to show you. But otherwise, you can use your calculator to get this number. So be prepared for it. Don't be surprised if you get K equal to 2.5. Okay. If you get 2.5, you are not done because we ask for the percentage. So you have to substitute yourself to get the percentage. The one in your book, most of them, you end up with the K equal to 2 and 3. I think there is one that you must arrive at 2.5 or something less. So be ready for it. It's a very nice result that, give you this range, more information that we need. So that is the application of the Chebyshev theorem. Okay, so now you have good idea. We can predict if the data set is given to you, you want to do something, you can predict what's going on, for your result. I just give you the result of the quiz. If I give you, the fair quiz or it was a standard one, it must satisfy, of course, it must satisfy the Chebyshev theorem. So I have all the grades, I can find the X bar and the standard deviation, and then by the Chebyshev theorem, get this minimum percentage that we have. Okay, so that is section 3.2. As I told you, very dense section. And of course, most of the question, all the question of the second part of after your quiz, for the test, something like 6 questions is coming from this section. Okay, and we practice for it. So this is going to be, that's the measures of variation. Okay, any question? So what's going to be next? We are going to go on a little bit more that we talk about this, especially this last theorem that we did, that Chebyshev theorem. That was a very useful one, and just give us the position of the data values. Okay, in terms of the standard deviation. So the next step is going to be what we would like to do. We continue with these ideas. We are going to introduce a measure that we call it measures of positions. Okay, measure of position is the same thing that, we want to know, can you give us a specific position for any data values. Okay, this was a general statement that we got it over here. So there are going to be a couple of them, and the conclusion is section 3.3. So what I'm going to do, there is two different topics on this chapter. There is something that we're going to use in future. We call it Z-score. I talk about that one, but I'm not going to finish it for the test, okay? Just the first part, because that would be too much for this test, but eventually we get it. So let's give an idea what is going to be this measures of, we call it measures of position or measures of relative positions. Especially this first part is going to be used quite a lot, okay? So let's see. So that would be a good place to give you one question on that measure too, but then we come back to it and we use it. So that would be 3.3. But even if we go on just the first part for the test, I'm going to stop there. Okay, so this is going to be measures of position. Sometimes we refer to it as a relative position. Relative position. We would like to get a tool, okay? Would like to get a tool that enable us to identify the position of, okay, the position of any data value, any data values. So what we are going to do, there are a couple of measures of positions that we're going to investigate, but one of them is very popular for the rest of the course, okay? So this new one, you see, when you want to compare these data values, again, we come back to this idea. We already talked about it. You may get data values of different measurements, okay? So you cannot compare them together. You cannot compare dollars, miles, gallons, etc. So what we did, we tried by the coefficient of the variation, we tried to find something which was independent of the units. And now, what else we are going to do in a statistic? You see the data values would be denoted by X. We call it X values, okay, X values. So what we're going to do, we are going to introduce a new measurements, if you like. If you like to get it in the language of the algebra, in the language of the algebra, we are going to get, that was the variable X, we are going to introduce a new variables. That new variable is going to be called a Z-score. You see, what is the Z-scores? Z-scores. The most popular one, you know, in statistics. So I'm going to get an idea of what is the Z-score means and why we like it. So what was the argument so far? You see the argument so far, libre algebra. I want you to just find this formula yourself. Then we write it down for you. You see, that's the x-axis, if you like, okay? That's going to be the x, we call it x value or the x variable. So what we do, we just put our values over here, okay, on the number line. There's going to be a center, okay? You know that center. That center is going to be the center that we pick. Is going to be what? Is going to be x bar. So that's going to be our center. Okay, this is going to be the center. And so far, what we did here, if a value is given to us, we just compare it to the center. Okay, so if you give me x here, okay, we already done this one. If you give me x here, so I want to compare myself to the x. Okay, so my deviation from the center, we already talked about it. Remember, this deviation from the center is what? This deviation from the center is the one that we call it x minus, okay, x minus x bar. So this portion is going to be x minus x bar. So that would be my deviation from the center. Okay, so you can measure it if you like. Okay, say, oh, x minus x bar is equal to the 2, 4, 5, 6. That gives you a number. But what we would like to do, we would like to bring a unit, if you like. See, when you measure something normally in inches, okay, yards, etc. So what we'd like to do is, we'd like to bring a measure, more familiar measure. By the Chebyshev theorem, we get the idea that the measure must be in terms of the standard deviation. You see, look at this one again, the idea that I am going to have. So by the Chebyshev theorem, this is the way you did it. That was again X bar, okay? That was X bar. Chebyshev theorem will tell you that you better use the standard deviation as a measurement. So this is going to be one standard deviation. This is going to be S. Okay, this is going to be S. So this is going to be X bar plus 1S, okay? So if you continue, that give you what? That gives you X bar minus 2S. And that is going to be X bar minus 3S. Okay, so the unit that we use is a standard deviation, okay? So this is going to be the same thing, X bar minus S, and this is going to be X bar minus 2S, and this is going to be X bar minus 3S, if you like. You see, this is the one that we use for the Chebyshev theorem to get these results. Now, what we are going to do with the z-score over here, you see, with the z-score, so what I would like to do is, I would like to measure this one in terms of the standard deviation. You see, this is X minus X bar, X minus X bar. I want to know this portion is, where is this portion? Is it here, 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 or whatever? Okay, how many standard deviation is going to be to the right or to the, okay, to the left? Okay, so this is going to be the one. What's the question? Shouldn't the right side be plus and not, which one is it? Yeah, yes, you are right, they are plus. Okay, so these are going to be plus. You see, so the situation that I'm going to have is going to be, you see, I want to know, this is, you see, X minus X bar. I want to compare this one to the standard deviation. I want to know how many standard deviation is X minus X bar. In order to find out, you have to divide it by a standard deviation. You see, if you divide the X minus X bar by S, that will tell you that this X minus X bar is which portion of the standard deviation. Which portion of the standard deviation. This portion of the standard deviation, I am going to call it Z. You see? So it depends where is X minus X bar. You see, if you get Z equal to 1, if you get Z equal to 1, this means the top and the bottom are the same. So this means this X minus X bar is one standard deviation from the center. So what we are going to do is, we just changing this. Is like moving the X bar. You see, it's like moving the X bar, which is the center of your X values, into the, okay, into the right, to the origin, if you like. So look at this one now. So what I'm going to do, instead of the X bar, I'm just using the 0. Okay, but this is in terms of the, okay, standard deviation. So this means 0 standard deviation. Then I put this one to be equal to the 1 standard deviation. 2, 3. And similarly, this would be what? And this would be a, okay, this would be a -1. And this would be a -2. And this would be a -3. So look at this. If you replace the X bar by 0, so this portion is 1 standard deviation from the center. 1 standard deviation from the center. This would be 2 standard deviation from the center, and that would be 3 standard deviation from the center. Now, instead of the X, I'm going to call this one Z. This is going to be Z values, or we call it Z score. Z score. So what's going to be the Z score? Z score is a measurement that will tell you where is the position of your values. Will tell you that how far, how many standard deviation your value is above the center, or how many standard deviation is going to be below the center. So if you get Z equal to 2 for your grade, this means very good, because you are 2 standard deviation above the center, above the 0. If your salary is going to be Z equal to -1, it's not good one. This means your salary is below the average. So instead of using these type of measurements, if you like, we just change it to the Z score. By the Z score, since you're just using with the numbers, it's just a kind of a standard measurement. And that would be very useful. It's just 1 standard deviation, 2 standard deviation. It's not dollars, it's not gallons, nothing. It's much, much easier to work with. And for the rest of the course, anytime you have the X, you change it to the Z and you identify your position with the Z. Okay, so that was just a motivation. But you have to understand it because this is very crucial for the rest of the course. So I write the definition and I come back to it again to explain it for you. What is the Z score? A standard. Okay, a standard score, we call it. Or Z score. Z score is what? Is the number of standard deviation. Is the number of standard. Number of standard deviation that a given value X is above, above or below, below the mean, the center, below the mean or the center. Okay, so it can be found, is found or computed using the following formula, following formula. The most popular formula in this course. Just make sure you get it right. And we are going to use it over and over and over in this course. Z equal to X minus X bar divided by S. This is S. Sample standard deviation. Okay, I just explained it again where this is the way you use it. X bar is a sample mean. Okay, sample mean, and S sample standard deviation. Sample standard deviation. And X is just the data values that you have. X, we call it raw data value, okay? If you like a raw, just data value for the time being. Data value. Okay, that's going to be the one. So the X values would be given to you, change it to the Z. Then there's going to be another problem that we do the other way around. We can use the same formula, just a little bit of algebra. Let's keep it as is. Then we come back to it. Okay. So as I explained over here, you see the deviation is X minus X bar. You compare it with a standard deviation, you divide it. You find out what's going to be, what portion are you deviating from the center. but you would like to express that portion in terms of the standard deviation. So that's why you divide it by S to get the Z. Now, by the idea of the Chebyshev theorem that we talk about it, or some other experiences that we have, this is going to be the Z is most of the time is going to be between -3 and 3, but it can be other numbers. So it's very important remark to have it over here again. Any question on this one? Let me give you this remark, give you a break, then we practice on it. This remark is very important. It costs you one problem from this section. Make sure you get it right. So what is this remark? We want to get the range of the Z. Much better than the Chebyshev theorem. You see, consider this is the Z score, Z axis we call it. So this is it. We start with the 0, 1, 2, 3. And this is going to be what? -1, -2, -3. Call this one Z score. Z score axis. Okay, that's one. Now, again, when you find the Z numbers, if the Z number is going to be between -2 and 2 in this range. If your number is in this range, we refer to it as a usual value or ordinary value. Okay, so if the Z is going to be in this interval, this is going to be called ordinary value, or the values. Okay, ordinary value is going to be, I'm going to write it down again. And if you are going to be here, I'm sorry, if you are going to be outside, you see, not this one. If you are going to be outside, means either here or here. In this case, your number is going to be called unusual. You've got quite a lot of problems in your book, unusual values. So if you are here, this is going to be unusual values. So I write it down for you. You must know that the ordinary, okay, ordinary or usual, ordinary values, okay, or usual values of Z in this interval, -2 less than equal to the Z less than equal to 2. So if your number is going to be between -2 and 2, it's the usual ordinary number. Otherwise, it is not going to be ordinary one, we refer to as unusual. Anything outside. You may be here or here. If you are here, your number is going to be less than, Z is going to be strictly less than -2. Or if you are here, your number must be greater than 2. So you have a number of the problem. We create a situation, then we ask you, is it the usual value or unusual value? So then you identify it for us, what's going on with this. So your grade, you know, the result of your grade is going to be all between -2 and 2. But somebody may do all the extra credit, etc. He or she may get one, you know, we may get something here, or that's Z numbers. So that would be not usual, but in that case, you know, in that set or test, that is what happened. Okay, so that's going to be the Z numbers. We have to practice. It's 11:25. I give it 10 minutes. We come back and we practice on this one. I put 4 problems for you on that practice one, but usually give you 1, maybe 1 or 2. But this is from now on, anything we want to do in a statistic, all the tables are given to you in terms of the Z, because that's easier. So we change. So that formula is going to be used over and over and over. And that's why I want to see it for the time being, because then we get to the probability and then we come back to it for the rest of the course. So it's not bad to get to know it now. in some statistic books, they don't talk about the no, but we like to see it and come back to it again. Okay, 10 minutes. We come back and we tell you it's all algebra and easy. How we're going to use it. Okay, see you in 10 minutes. Okay. Okay, let's give you a couple of examples to see how we're going to deal with the z-score for the time being. Some values would be given to, you're going to find the z, and sometimes z would be given to, you have to find the x, the other way around, because you're going to use both of them. So we just practice on this one and know that the usual value is going to be the one which is going to be between -2 and 2. Otherwise, it's going to be unusual. Okay. So just make sure you know these for the problems that we're going to have. Okay. So just give you a couple of them. So the first one is something's may be given and we ask you to explain it for us. Okay. So this first one is we have a sample of 2000 high school graduates and the SAT records or values, scores. So suppose a sample of 2000 high school, 2000 high school seniors verbal SAT score. Scores is selected. Okay, so we have 2000 students and we select the scores and we find the following. The mean and the standard deviation of the score, and the standard deviation of those scores are given by their mean score is 550 and the standard deviation is 75. Okay, so for this type of problems, these two values would be given to you. Now we pick one. Suppose somebody like Joe. Suppose Joe. Okay, that's it. Joe Smith. Joe Smith's score is 475. Okay, so the X value is 475. So we want to know what's going to be the Z score. Okay, what is his sample Z score? We want to change it into this new system and find the corresponding values for it. Okay, so a straightforward problem. So the solution is going to be, so what we have the X bar, which is 550. Okay, it's going to be 550. And we have the S, which is 75. And the X number is given to 475. Okay, 475. And then we want to find these numbers. Okay. So we got the S, the formula Z equal to X minus X bar divided by S. Okay, make sure to write it correctly. It's X minus X bar, not the other way around. Now we substitute. That gives us a 75 minus, okay, I'm sorry, it's 475. 475 minus X bar, which is 550. Okay, 550 divided by S, which is 75. Now we substitute, it's going to be negative, simplified 75 over 75. The result would be a -1. Okay, so Z is equal to -1. What does it mean about his scores? Any suggestion? Joe score, Z number is -1. What does it suggest?
Joe's score was below the mean, or the average? Was below average?
below the average. Let me
Because it's -1, right? So it'd be below the average.
just fix my speaker. Repeat it again.
It would be an ordinary value.
Yes, ordinary value. Yeah, you see z equal to -1 means his score is one standard deviation below the mean. You see, when you talk about the z is in terms of the standard deviation. So you have to always, go with the standard deviation. Remember, this is a portion of the standard deviation. So yes, we know that this is going to be ordinary value. But the meaning is going to be -1 means one standard deviation below the center, if you like, okay? So his score is 1 because it's a -1, 1 a standard, okay, 1 standard deviation, 1 standard deviation below, okay, 1 standard deviation below the sample mean. Sample mean. Okay, or it's in your book, they ask you whether this is usual or unusual. You can say that it is an ordinary. Specifically, we are going to ask you on the test. Okay, it's an ordinary value. Ordinary value. So this means you got a not bad. It's not very good one, but at the same time, it's not bad. Okay, it's usual or it is okay, and it is ordinary score. Okay, any question? So when we get to your test, we are going to create a situation, okay? A situation that you have to make some comment for us, okay? Reading something from everyday life when we want to talk about it. And when you get to you get a couple of them in practice one, if you look at it. That's so be prepared for this type of interpretations. So this is the first one, just the usual number would be given. Any question? So get to know the Z, because this is going to be very important for the rest of the other things that I forgot to tell you, that this is going to be for future. If you have a place, if you just make a note here, because that's very important. I forgot to tell you this number, this is the one we're going to use in future. In future, anytime we work with the Z, okay, over here, you may get a decimal number. If you get the decimal number, you must round it to the 2 decimal places only. Okay, so I just make a note here. Okay, make a note. We are going to get to it and I'll explain it again, but round the Z value, okay, to the 2 decimal places. Because we are going to use, everything we are going to do in this course would be depends on this Z value in future, not now, but just give you a hint, get used to it. Even if you use your calculator, make sure you run that to the 2 decimal places only to get these numbers. One of those tables that, look at this one, not for now, for future. These 2 pages, these 2 pages would be everything in a statistic later on. You don't need anything really, anything, even any calculator, only these 2 places. And we're going to tell you, if you check this table, you see this table would have only 2 decimal places for the Z numbers. These are going to be the Z numbers that we're going to have. For example, this is -3.4, and these are just the second decimals that we're going to have. You will see it, I'm not going to use it now, but I'm just want to convince you that why I'm telling you 2 decimal places. If you do everything with the calculator, they may consider more than 2 decimal places, but get used to it. Round it up to the 2 decimal places only. Because all the problems that we're going to have in this course would depend on this number. And I'm going to get back to it and explain it again. not for the time being, it's not going to be a big deal, but in future, it's going to be. Okay. So that would be, that is, yes, we have to wait. We give you more examples. No, this is not the only one. Okay, so that's going to be the one. At the moment, you are not going to have anything hard other than just get to know it. Let's have another one to see what I'm talking about. The other problems that you are going to have at the time, for the time being, are going to be this form. For the time being, it's just application to formula, nothing else. Okay, what's going to be the next one? See, the next one is, for example, the average. Okay, the average teachers. The average teachers, let's say teachers. Okay, teacher salary. Average teacher salaries in a school, in a particular state. The average salary is $54,166. Okay, so that's the mean salary of a teacher in a particular state. So what do you want? If the standard deviation, if the standard, okay, standard deviation, if a standard deviation of the salary is $10,200, we want to find the salary, find the salaries. Okay, salaries correspond. Salaries corresponding to the following z-score. It's the other way around. Following z-scores. Okay, so in this case, the z numbers are given to you. They ask for the actual salary. Okay, so we have a teacher whose salary z-score is 2. We want to know how much he or she is making. Okay, so be careful. So these following z-scores, so the z-scores are given to you. In this case, the x, the actual number, the raw number we call it. So we have two cases, the case that the z is equal to 2, and the case that is going to be negative 1.6. So you must know that this is a good salary, because z equal to 2 means the salary is 2 standard deviation from the mean, or above the mean. But this is not going to be as good as the other one. It's a negative 1.6. So this means this salary is what? Is 1.6 below the, okay, below the average, below the 1.6 standard deviation below the mean. Okay, so this is how we're going to do these type of problems. Just make sure you get it right. So for the solution, the general information, you have the mean salary of the teachers. Okay, the mean salary is 54,166, and the standard deviation of the salaries are going to be 10,200. Okay, that's the general information that we have. So in the first part, we have a teacher whose z salaries number, z number is 2. So you want to find the x number, you see, you want to find the x. So we write the formula. What's the formula? The formula is z equal to the x minus x bar divided by s. I can give you another formula, for the x, but we just leave it for the time being. Substitute, get this number. So your z is equal to 2. So there's going to be 2 equal to the x is missing for this problem. See, you don't have the actual salary. X is missing minus x bar. The mean salary is 54,166 divided by s, which is 10,200. You see, you have to solve for x. Solve for x. Solve for x, we cross multiply. Okay, it's algebra. just cross multiply. Okay, if you cross multiply, that give you what? It's going to be x minus, that give you x minus 54,166, which is times it by 1, that give you the same one, which is going to be equal to the 2 times, okay, 2 times 10,200. Okay, to find the x. Any question? Just solving this equation. So multiply and just continue to get this number. So what we have is going to be, so this is going to be x minus 54,166. Okay, is equal to, you multiply this one, and that gives what's going to be 0, 0, 4, and 20. So add 54,000. So it's going to be 20,400 and plus 54,166. And if you add them together, that gives you the salary that corresponds to that number. Okay, if you add them together, that number is going to be what? It's going to be 74,566. So the salary is a very good one. $74,000, $566. You see, that's going to be the one. So it's a kind of converse problem. A Z number was given to you, you recover the actual number, which is going to be the X values. Okay, any question? So be prepared for it. You know, we know that it must be a good one because Z was equal to 2. So the salary is 2 standard deviation above the center. And then we find out that it's going to be 54,566. Okay, so we get the second one. The second one is Z is negative. It's negative 1.6. Negative 1.6 means 1.6 below the mean. Okay, so again, you want to find the X values, the X salary for this one. Okay, so again, go to the formula. The formula is Z equal to the X minus X bar divided by S. Substitute, the Z is a negative 1.6 is equal to the X is the missing one. The average salary is 54,166 divided by S, and the S is 10,200. Okay, any question? So cross multiply. Again, cross multiply is like 1. So it's going to be X minus 54,166, and this is going to be it's a negative 1.6 times it by 10,200. Okay, continue. It's going to be X minus 54,166. Multiply these two together. You can multiply using your calculator. That gives you a negative number, and that would be 16,320. Okay. So add the 54,000 to the other side. So X would be equal to 54,166 and the minus 16,320. And if you subtract it, so the result would be what? Dollars is going to be $37,846. So for the teacher with the Z number, negative 1.6, as you can see, the salary is less than the average, because the average was what? 54,000. Okay, any question? So be ready for it going from Z to X or X to Z. Z is the standard score and the X is a kind of raw score, we call it. Okay, this is just the actual one. Then we are going to raw score and get this number or these values. Okay, any question? So that's one version. The other version is comparison. You can use the Z number just to find out if you have something, okay, in two different data sets, for example, and you want to get a better idea, you are going to use the Z. So I'll give you another one. Have it in your book, you know, they got many examples or problems in your book, and you have 4 in that practice one. Give you 2 questions on the Z-score on the test. Okay, let's see how we're going to compare these comparison. So we are going to compare 2 grades. See, you're taking 2 courses. For example, you have a statistics and calculus, and you have your grade, and you know the average of the class. You want to know your position, your relative position in those 2 classes, which one is better. Okay, so this is it. Example is, let's say Anne. She scored, okay, she scored 60. 60 on a math course, math test. Okay, she scored 60 on a math test with a mean. Okay, with a mean of 72. And a standard deviation. And a standard deviation. And a standard deviation of 50. So that's for the math course. But you got another course, you got physics. So she scored 35. She scored 35. 35 on a physics test. Okay, on a physics test. Maybe this one. With a mean. Okay, with a mean of 50 this time. Mean of 50 and a standard deviation of 20. And a standard. Okay, standard deviation. Okay, it's going to be, this is the physics grade. So a standard deviation of what? Of 20. So that's the situation we're going to have. She wants to know which one is better. What is the her relative position? We compare the relative position in the maths and the physics. So I would like you to compare. Okay, compare her relative, relative position on the 2 tests. Two tests that we are going to have. Okay, of course, you know, relative position, you have to compare the z-scores. So you have to find the z-score of each test, and then you compare them together to find out which one is going to be better, okay? So relative position can be done by comparing the z-score. So what we're going to do, we're going to compare, okay, compare z-scores, z-score of the 2 tests. The 2 tests. Okay, so take them one by one. The first one is going to be mathematics, okay? The math, that's it, math test. Information that you have, the X bar, the average is 72. The standard deviation is 15. Her grade was 60. Her C number is missing. That's it. You have all the information that you need to write the formula, substitute, get result. Okay, the formula for the z is equal to, it's going to be x minus x bar divided by s. So x is 60, x bar is 72, and the s of 15. If you subtract it, that gives you negative 12 over 15. You can simplify it if you like, you just use your calculator. And simplify it by 3, that gives you 4/5. 4/5 is a nice number. That gives you negative 0.8. So z, you may call it z1. For the first one is a negative 0.8. So for this one, she is going to be 0.8 below the center for the math course. Any question? Check the second one, the physics. Okay, physics test. The mean of this course is 50 and the standard deviation of 20. And the error score is 35. And you want to know what's going to be the z number for this one. Okay, again, substitute. Just the formula is going to be x bar minus x divided by s. So the x bar of the x, I'm sorry, it's x minus x bar, I made a mistake. X minus x bar over s. So the x is 35. And the x bar of the 50, s of 20. You subtract it, that gives you a negative number on the top, negative 15 over 20. Again, you simplify it by 5. That gives you negative 3/4, which is easy. It's a negative 0.75. So you may call it Z2. Okay, you may call it Z2. Z2 is going to be negative 0.75. So for the physics, she is negative 0.75 below the center. But for the math, she's 0.8 below below the center. Which one is better? Physics or mathematics? Physics, yes, because the Z2 is bigger than the Z1. Okay, physics. So the Z2 is, okay, we note that Z2 is better than Z1. Okay, so her position in her physics. Okay, physics score is better or is higher. It's going to be higher, higher score to get these numbers. Okay, so this is, give you various form, if you like, for the time being, of course, the way we're going to use it in future is going to be different, but this is going to be, this is going to be the case, okay? Yes, physics is better. Intentionally we give you negative numbers to see how we're going to compare them together to get these numbers. Okay, any question? It's very, very nice, nice measurements. We see it, see a score. And when we come back, we are not going to do much about it for the rest of this section. There are two compare, we have something we call a percentile for the positions, but when we are done, when we come back again for the rest of the course, only the Z score that we are going to use in this course. That's why we want to get to know it, to get these numbers. For simplification for 5, what do you mean? Simplification by 5, we just divide by 5. That's it, 15 divided by 5 is just a fraction. We just simplify. 15 divided by 5, we get 3. 20 divided by 5, we get 4. So that gives you 3/4, okay, to get these numbers. Okay, this is how or where we are going to give it a test. We are not done with this section 3.3. It's just beginning of this section, which is very important, more than much better than the rest of that. Okay, to get these results. So we go over that practice test on Thursday. I just quickly give you, because some of you missed one question on the quiz. Let me just bring that quiz and tell you what you missed. Any question on this one? So this is where we're going to give you the test. 11 questions, something like 4 from the test, 4 on the quiz. And the rest are going to be from these new parts that we did. Measures of centers and measures of variation. And we have very nice problems on that practice one that we're going to review it on, okay, on Thursday. We are not going to give anything else, just that part. Okay, so that's going to be the one. If your quiz is missing, you have to tell me where is your quiz. If you email it to me, forward it again. I got a couple of them this morning. I just checked. You email it to me. If there was anything on the canvas, I just did all of them. So if you don't see your grade, if you email it to me, forward that email. I will grade it for you before Thursday. Okay. I know that there are 3 or 4 people that they haven't got it. Okay. So this is going to be, what is that? 3.3 part 1 as far as this section is going to be on the test. Yes, that's a Z-score, but we are not done. There is 2 more concepts. It's very big sections. We are not going to cover it before that test would be too much. But from 3.3, we give you Z-scores only. There are percentage, box plots, quite a lot. We talk about it after your test. But the topics of the test are the one on your quiz and the practice test, and I review it. Let me just, we have a couple of minutes. I like to just take that quiz because we are going to give you the sampling again, and some of you missed the stratify and the clustering. That was the one that you missed. Okay, let me bring it back if I can. That was quiz. But most of you did very well. Nothing to worry about. Okay, so quickly, let's see. Okay, can you see it? I just explain it because most of it did very well. That's why I didn't post the solution. If I get time, I may do it, but we don't need it really. You see, that's the first one. The first one, we want to describe it. You see, anything that's related to the sample is descriptive. Anything which is a prediction and population type is going to be inferential. So the first part is descriptive. Okay, just give you a report. And the second part is inferential because you're just making a general statement. So that's a part 1 and the part 2. Part C is clear. It's observational because you just observe and make a note. And the second part is experimental because they divide in 2 groups and then they explain the procedure for you. So we may give you one again. So just a couple of you missed the first part, not the second. Okay, that's number 1. Number 2. Number 2, this is where you miss. We give you this question again. Be careful. The type of the sampling, the first part measuring length of the time every 5th. Because of the 5th is systematic. That's a systematic. This is part B that some of you missed it. Okay, the difference between clustering and stratified. You should read it carefully to see which one is it. You see, divide the user of a computer online services into different age groups and then select a random sample from each age. You see? No. From each age. From each age for surveying a mother. You see, since you divide them into different groups, but you pick sum from each of the categories, it's stratified. Okay, so that's the stratify, the second part. The third part is random because they say pick a random sample. Random sample. And the last part, you see, select 5 zip codes and induce every apartment. It's clustering because there are many, many zip codes. You just pick 5 of those. So if you miss a point, you miss this one. Some of you missed the between the B and the D. B is stratified because in your final sample, you give everybody a chance to be inside. So that's what they stratify. And the last one, because you just pick 5 zip codes, okay? So this must be a clustering, okay? Okay, that's cluster. So just make sure you don't miss it on the test. And the other one that's going to be coming on the test is this one, measurements that we talk about it. And we talk about it if the measurements are a categorical one, no numbers. If you can rank them, it's ordinal. If you cannot rank them, it's nominal. When we talk about the numbers, if the number refers to a temperature, it's interval. Otherwise, it's ratio. So the first one, rating, is ordinal. The second one, horsepower, is ratio. Marital stat is nominal. Temperature is interval. Okay, so that's number 3. We give one again. And this one is mostly did it all right. W would be 15, and you divide into group. A couple of you just didn't care about the 15 and what we talk about it. You just did your own sampling. You have to follow the rules. Our rules is the number of the classes is given to you and equal to the 5, and you have to find the W. The W would be 15. So the distance between the classes are 15 units. So you have to follow these rules. Not, in general, yes, you can group them as you like, but to get the points, that's what number 1. Okay, so W15, otherwise would be fine. Number 5, the graphing one, again, most of you did all right. You have the frequency, you have to find the relative frequency for the, okay, for the construct, no, you have the frequency, you need the midpoints and the cumulative frequencies for OJV. Okay, so you had one column for the midpoint, one column, you just add the frequencies together and give us the 3 graphs. So that was a standard. Again, most of you did all right. 5. 6, again, same thing. It's a categorical one. So the name of the days are going to be categories. We are going to count them. How many Mondays, how many Saturdays, how many Fridays do we have? Fridays is going to be the most frequent one. Friday, I think it's 18 Friday. You put those numbers together and you find the relative frequency, which is percent, and Pareto chart. You know that Pareto chart, you have to start with the highest hour. A couple of you just didn't take that one. Okay, so it would be the case. So make sure that go back, check your quiz. If you missed that, okay. If you missed this, be careful about this temperature, which is interval. But if you missed the point, you missed it here. The difference between B and D. Just think about the final answer, okay, to get these numbers down. So 4 or 5 from here would be given to you. Just study it. If you have any question, let me know. And that's it. I have to go. My first class face-to-face. I go back to the Palmer College to see what's going on today. But for you, we come back again on Thursday. Just study that practice one. We put them together. So our first test is going to be up to the whatever we did today. Okay, that's it. Any question? Have a good one. Take care. See you on Thursday. Bye-bye.